right, so 721, core problems. What makes a quadrilateral special? You'll notice a little bit of a shift. We've been talking about triangles for most of chapter 7, and now we're going to expand into quadrilaterals. So when we've talked about quadrilaterals in the past, we've talked about parallelograms, rhombus, kites, and others, and you'll notice that you have some attached filled in properties of quadrilaterals with the notes that go with this section. Normally what we would do is we would sort of brainstorm and fill those in together in class, but we've provided them for you as a reference. And we're going to start by talking about, before quadrilaterals, just talking about some things that have to do with lines and graphing. So it says, review some of the algebra tools you already have. Consider two line segments, A, B, and CD. Given that A is at 0, 8, and B is at 9, 2. C is at 1, 3, and D is at 9, 15. Draw these two segments on a coordinate grid. Calculate the length of each segment. So if we want the length of the segment and it's not horizontal or vertical, one of the tools that we have is the Pythagorean Theorem. So we can make sort of an imaginary right triangle out of this segment and say, okay, well, if it had a rise and a run, if it had a height and a base, what would it be? So this one would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. So this would have legs of 8 and 12. The other one, AB, that would have, go down just a little lower, there we go. This would have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And so what I did was I set up the Pythagorean theorem twice. 6 squared plus 9 squared equals c squared, because the two that we have are legs and we are looking for the hypotenuse in both cases. So I would have 36 plus 81 equals the hypotenuse squared, which would be 117 equals c squared, and we would have to square root both sides, and it would be approximately 10.8. So segment AB is approximately 10.8 units. And then the 8 squared, 64, plus 12 squared, 144. If I add those together, 208, and square root both of those, we would get approximately 14.4 units. So the segment, we can say segment, let's see, this one, let's say segment CD equals 14.4, is approximately 14.4 units. And because I'm talking about the length, I actually wouldn't have that segment symbol over the top of it. I would just have the CD. And then the other one would be AB is approximately 10.8 units. So don't forget, Pythagorean theorem can be used to find the length of something if it is not horizontal or vertical, and you won't necessarily see a full right triangle, but you may need to create your own. Write the equation for line AB and the equation for line CD. So now the notation is saying if we were to extend this thing forever in both directions and it were no longer just a segment, what would it be? So first of all, line AB, we have a y-intercept for it, which is 8, and we'd need to find the slope. And it looks like we're going down 6 over 9. So the slope would be negative 6 over 9, or negative 2/3. So it would be y equals negative 2/3 x plus 8. That one's pretty straightforward because they gave us the y-intercept was 8. The second one, the slope is going to be a rise of 12, run of 8. So if I divide both of those by 4, we get 3/2. I also need the y-intercept. So y equals 3/2 x plus b. If I choose one of the points, I would probably choose 1, 3, just because the numbers are smaller. And multiplying by 1 is pretty easy. Take away 3/2. Take away 3/2, which is the same as 1.5. b is 1.5. You could also have 3/2. I would take either one. So the other equation is y equals 3/2 x plus 3/2. What is the relationship between segment AB and segment CD? That is, are they perpendicular or parallel? So the first one had a slope of negative 2/3. The second one had a slope of positive 3/2. So those are, in fact, opposite reciprocals. We would say they are perpendicular the slopes are opposite reciprocals. All right, so use algebra to find the coordinates of the point where segment AB and segment CD intersect. So if we want to do that, you'll notice they both start with y equals, so we would be using the equal values method. I would set negative 2/3 x plus 8 equal to positive 3/2 x plus 3/2. I don't want to deal with all of these fractions. So personally, I would multiply everything on the left by 6 and everything on the right by 6. And I did that because my denominators were 3's and 2's. So I'm going to have negative 4x plus 48 equals 9x plus 9. And that was just by distributing 6. So I'm going to solve. Negative 4x plus 48 equals 9x plus 9. I'm going to add 4x on both the left and the right. I'm going to subtract 9 from the right, subtract 9 for the left. For 39, 9, 10, 11, 12 equals 13x. Divide both sides by 13 and get 3 equals x. So I've got one part of the coordinate. Still need to go back. I'm going to choose, I'll choose the negative 2/3 x plus 8. Has less fraction going on. And when I plug in x is 3, it will cancel that 3 in the denominator. So y equals negative 2 plus 8 and y equals 6. So the coordinate where they intersect is going to be 3, 6. So a lot of review there, not only from chapter 6, where we were solving systems of equations, but also a lot of different older material as well. Things to do with, opposite reciprocals being perpendicular lines and so forth. I think that was chapter 3, actually. 786, am I special? Well, yes, I am. But we're talking specifically about this picture. Shayla just drew quadrilateral SHAY, shown it right. The coordinates of its vertices are 0, 0, 0, 5, 4, 8, and 7, 4. Shayla thinks her quadrilateral is a trapezoid, meaning that it has the special property of having one pair of parallel sides. Is she correct? So first, I would look at the top, and I would say to get from here to there, I would go up 3/4, making this one have a slope of 3/4. This one, I would go up 4/7, making it a slope of 4/7. So we would say, no, the slope 3/4 is not equal to the slope 4/7, meaning that they're not parallel. And clearly, I would say clearly that the others don't look parallel either. But if you wanted to check, I suppose you could. This one's a vertical line and this one's not a vertical line. So not going to be that pair parallel either. All right. Even if Shay's quadrilateral does not have a special name, it may still have some special properties. Are any of the sides congruent? And explain how you know. So if we wanted to, we can say that this one, we already said had a slope of 3/4. We know that there is a special triangle with sides 3 and 4 in a right angle. That makes the missing side or the unlabeled side a 5 length. We also know that this side has a length of 5 because it's vertical, so that's pretty easy. This one has a negative 4/3. If you want to measure it on the outside, just so you can see it a little bit easier, you can say it's over 3 down 4, making that side also a 5. So interestingly enough, we do have some congruent sides. Does it have any right angles? So we've got a 3/4, right? This one had a slope of 3/4. This one has a slope of negative 4/3. So it does have another interesting property. It does have a right angle in it. So that's a yes. We had, a pair of perpendicular sides. And last, it's asking us to find the perimeter. Well, so far we've got 3 of the sides are 5, 5, and 5. The last side we said had a slope of 4/7. That means we can sort of pretend, or not pretend, but we can imagine a triangle with sides 4 and 7 for the legs. So we could do 4 squared plus 7 squared equals x squared or c squared because it's a missing hypotenuse. And so we'd get 16 plus 49 equals c squared, x squared. It doesn't really matter what letter you use. If we're going to use c, that's fine. 65 equals c squared. And when we square root both sides, that missing side is approximately 8.1. We don't need to check the other two up here. We know they're 5 because they're a Pythagorean triple. We don't need to check the 5 over here because it's vertical. So now if we want the perimeter, we can add the 5, 5, 5 and the 8.1. So we're going to switch this to approximately. The perimeter is approximately 23.1 units. If you wanted a more exact answer, you could leave that 8.1 as the square root of 65. But since the others are all whole numbers, it's not really going to be all that helpful. So yeah, this does have some special properties, but unfortunately not a trapezoid.